been talking about inverse operations your whole entire math career. The inverse operations would be addition and subtraction, and then multiplication and division, and then squares and square roots, logs and exponents, and taking the integral and taking the derivative. Okay, so those are all different inverse operations. What we're going to be looking at today are inverse functions. At the end of this lesson, you'll be able to find the inverse of a function. Right, the first thing that I'm going to do is just give you a few properties, and then we'll do some examples so you'll know exactly what I'm talking about with inverses. First of all, the inverse function of f, it's going to be denoted by f, and then it's the power of -1. It doesn't really mean it's to the -1 power, it's just notation. The way that I would read this is not f to the -1. I would read it as f inverse. So this will get just a little bit confusing. There's not a button on your calculator, even though we have a button that looks like this. It's not the inverse button. All right, a function does not need to have an inverse, but if it does, the inverse is unique. There's just one of them. Okay, if my function contains the point AB, then the inverse graph contains the point BA. And hopefully you notice from this the x and the y are switching spots when you're finding the inverse of a function. So the graph of f and f prime are reflections of each other over the line y equals x. So when I switch the y and the x, that's when I'm finding the inverse of a function. So let's draw a couple examples so you know exactly what I'm talking about with inverses. Okay, let's say this is my function f. Okay, if I would like to find the inverse of f, basically what I would need to do is we're going to draw the line y equals x, and then we're going to reflect this graph about the line y equals x. And you notice if I do that, not a very good example, but this would be f inverse. I reflected it about the line y equals x. It basically turned that picture on its side pretty much. Okay, another example would be if I have, let's see, so if we've got the natural log function going on here, we've got f, and I reflected about the line y equals x. Notice I get something that looks like that, and that would be the inverse. So that kind of gives you an idea that this was the natural log function, and this was the e to the x function. Those two are actually inverses of each other because they're reflections about the line y equals x. Alrighty, let's see if we can actually find an inverse and do a little bit with that. So let's consider the function f of x is equal to the square root of 2x minus 3. Okay, first question, if 2, 1 is on the graph of f of x, what point is on the graph of the inverse? So we basically know, since the inverse is a reflection about the line y equals x, basically all we need to do is switch the x and the y. So the point that would be on my graph of my inverse would be the point 1, 2. Okay, the next thing is that we'd actually like to find the inverse, so I'm actually going to find an equation for the inverse. The first thing that I'm going to do, instead of using f of x, I'm going to use y. So we're going to have y equals the square root of 2x minus 3. I know with an inverse, we switch the x and the y values, so I'm going to let the x be y and the y be x. So x equals the square root of 2y minus 3. And now I'm going to just solve this equation for y. So we're going to square both sides to get rid of that square root. So now I'm going to have x squared equals just 2y minus 3. And then from here I'm still going to be trying to solve for y. So from here I'm going to add 3 to both sides. So I'll get x squared plus 3 equals 2y. And then to get the y by itself, I'll just divide by 2. So I end up getting y equals x squared plus 3 over 2. And basically that I just found the inverse, so to let people know that that's what that was, I will just change my y to an inverse symbol. So that is an equation for the inverse. And now notice I can graph both of those. And it says to show that two functions are inverses graphically. So let's go ahead and grab our graphing calculators, and we will graph those and show that they actually are inverses. So get your calculator. Alright, got my calculator out. I'm ready to go ahead and graph y1. So let's do that. That will just be my original function. So it was the square root of 2x minus 3. So 2x minus 3. Okay, and then my inverse function was, I'm going to put the x squared plus 3 in parentheses here, so we're going to have x squared plus 3, and that was divided by 2. And then the third equation I'm going to be putting in is because to show that it's an inverse, I want to show that the reflection's about the line y equals x. So I'm actually going to let y equals x be one of my equations as well. Okay, then we can go ahead and graph it. And you will notice if I ignore the left side of that graph, the left side of that ending parabola, I do get that those two functions are inverses of each other. And we can ignore that left side because the original function was not even defined over in that spot. So if I go back to here, let me just go ahead on my notes now and draw it. Oh. Okay, so this looked something like that, and we had the line y equals x, and then we had, I'm only going to draw this part of it because that was the only part that was actually the inverse of it. So this was f, and this was f inverse. And so we did show that those two functions are inverses graphically. So hopefully now you can find the inverse of a function.